What values of x would make this relation not a function? Well, it's important to understand what is a function so you can figure out what would make it not a function. If you're talking about a graph, it's real easy to determine what a function is using the vertical line test. Like if you had a sideways parabola, and this you could draw any vertical line through it and hit the graph twice, then it's not a function. If you can't draw a vertical line anywhere through it and hit it twice, once each time, then it is considered a function. But when you're talking about ordered pairs, well, then this is called a mapping. So in the first ordered pair, the 7 maps over to a 3, and that's okay. The 10 turns to a 9. The -4 goes to a 5. Now, there's something that you can't have and it be a function. That is, if, say, the 7 went to 2 different things. It's like killing 2 birds with 1 stone. You can't do that. So if the 7 also went to 9, then it would not be a function. So what you have to look at is the fact that if x were, say, a 7, you would have 7, 3, and 7, 3, and 7, -2, like in the function over here. And so that would not be a function. So 7 is an option of one of the numbers it can't be. And since there are a couple of other points on that, if this were not a 7 but a 10, then 10 would go to 9 and 10 would go to -2. So if it were 10, it wouldn't be a function. The same thing with the last one. If it were a -4, it couldn't be a function. So you have to consider that if you can use the words only goes to, so you have to use the words only goes to, just not going to erase. If 7 only went to 3, it would be a function. If 10 only went to 9, but if you replaced it with a 10, it would go to -2 and 9. So if you can say the word only goes to for each one of these, it would be a function. So they ask you for what would make it not a function, which would be if it matched one of the other first numbers, the x, and went to the different y.